When we talk about something like an entity, a certain event, or a person and its relationship to other things, we often mention the same thing multiple times and tend to use different expressions. For example, Philip plays the bass because he loves it. With our amazing brain and knowledge of the language, we're capable of resolving that he refers to Philip and it to the bass. Unfortunately, machines don't have it as easy as we do. But why does it matter? A good example could be a dialogue system designed to communicate with users. But in order to understand a user, our system must be able to resolve references in conversations. So in this example, the user wants to schedule a meeting. The information about the time is stated in the next sentence. But here, the meeting is referenced with the word it. So to be able to schedule the meeting at 10 a.m., the bot needs to know that the user refers to the meeting with it. And for our beginning example, it should resolve the sentence to Philip plays the bass because Philip loves the bass. In the field of natural language processing, this task is called Coreference Resolution. And in this video, we'll teach our machine how to do it. Hey everyone, my name is Edward, and today I'd like to show you our new and exciting Coreference Resolution component in spaCy, called Coref. This component allows you to resolve references of entities across sentences and merge them together into the same cluster. Currently at this time, our Coref component is still in an experimental state, and thus hosted on our spaCy experimental repository. But it can already be used if you're interested in exploring how this feature can be beneficial for your own work. With the release of Coref, we also provide an English pre-trained Coref model, which you can download and try out yourself. The installation wheel can be found in the 0.6 release of spaCy experimental and installed via pip. So in spaCy, the model can be imported as usual with spaCy.load and then nCoreference web trf. So if we feed our beginning example sentence into our pipeline and print out .doc spans, we get the extracted clusters from the Coref component. In this case, we get Philip and he and the bass and it. So you can find the generated information from the Coref component in the doc.spans attribute. This video will be a short tutorial on how to use the spaCy Coref project, which shows how to train a Coref pipeline with the OntoNodes dataset. We also show how to utilize the pipeline to resolve reference in the text. If you're interested in how Coref works internally, we have an amazing blog post by Ákos and Paul, in which they show the design and the architecture behind it, step by step. The full Coref pipeline consists of 5 different components. However, in the project, we will separate the training into 2 pipelines. First, we have the Coref resolver pipeline, which consists of a transformer and a Coref component. We will then use the pipeline to generate training data for the next pipeline, the span resolver pipeline, which consists of a transformer, a synthesizer, and a span resolver component. Once both pipelines are trained, we assemble them together into one full pipeline and add one additional component, the span cleaner, which is used to clean up the outputs and make it more readable for the user. Alright, to get started with the project, make sure you start in a new fresh environment and have version 0.6 of spaCy experimental installed. To do that, use pip install spaCy experimental 0.6. This will also install the right spaCy version for us. spaCy's project framework allows us to download the Coref project within the terminal with this command, spaCy project clone experimental /Coref. This creates a folder called Coref with all the assets, workflows, and the project configuration file. Let's open up the folder and make sure that our environment has everything the project needs by using pip install-r requirements.txt. This will install the nCore web large language model and spaCy transformers, which we need for using transformers with spaCy. As I mentioned in the beginning, this project uses the OntoNodes dataset, and you need to have access to this dataset to be able to use this project. But this project can also be used as a template if you have your own Coref annotations. The only thing you would need to change is the preprocessing, and we're more than happy to help you in the spaCy discussion forums. So if we look at the README, we see it gives us a detailed explanation of the requirements of the project and how to use the OntoNodes dataset. It also shows us how to install spaCy with GPU support, which is recommended for training the transformer and the Coref component. At the bottom, we get a list of all possible commands. So first we start with preparing the data for the Coref resolver pipeline with prep OntoNodes data and preprocess. Afterwards, we use the train cluster command to train the first pipeline. We will use the train Coref pipeline to generate data for the span resolver with prep span data and train it with train span resolver. Then we assemble both into the full Coref pipeline with assemble and can use the evaluation script to look at the performance of the whole model on some test data. When we go into the project config, we get a more detailed look into the different variables of the project, like the GPU ID or the path to the onto-nodes dataset. We also get a closer look to the individual commands. So every command has a name, description, the actual scripts that will be executed, the dependencies, and the expected outputs. These commands are fully customizable, and the project framework will automatically throw an error if any of the dependencies are missing. To make sure that we have everything, we type in spaCy project assets, which gets us all the scripts we need for the onto-nodes processing. To run a command, we use spaCy project run and then the name of the command. So our first command will be prep onto-nodes data, which will prepare the onto-nodes dataset for training. Depending on your device, this might take some minutes. After it's done, we use the process command to convert the data to our .spaCy training format. For the Coref resolver, we now have a train, def, and test file. We can now train the Coref pipeline with the train cluster command. This will take a while because both transformer and the Coref component are computationally expensive. This took roughly 2 hours on our GPU machine. While training, we get 6 different metrics to track. We get the transformer loss, the Coref loss, the F-score, precision, and recall of the Coref, and a general score, which is the weighted average of the other scores. We will let it train until the training loop automatically stops when no improvement is detected, or when we reach 20 epochs. After training is done, we have 2 new models in our directory. First, model best, which is the model with the highest score, and model last, which was trained in the last iteration. We can now use the pipeline to generate training data for the span resolver component. For that, we use the prep span data command. Because we're using the Coref pipeline here, this will also take some time. After it's done, we're training the span resolver with train span resolver. And for the span resolver, we get its loss and its accuracy. Once both pipelines are trained, we can use the assemble command to assemble them to one full pipeline. We can then use the evaluation command to evaluate the whole pipeline on some test data. Here we get 5 metrics. First, the LEA metric, which stands for Link-Based Entity Aware metric, and it measures how similar the predicted clusters are to the gold ones. Then we have the total amount of gold and predicted clusters. Then, due to some possible token alignment errors, the evaluation script can skip certain clusters. And at the end, we get the repeated mentions, which shows how many times a certain mention appears in multiple clusters. Now we have a trained spaCy model, which is capable of Coreference Resolution. We can use the code from the beginning to replace our pre-trained model with the path to our trained model, which will be training/Coref. And if we run the code again, we get the same 2 clusters, Philip and he, and the base and it. When processing text with our pipeline, the model outputs a doc object with the coreference information stored in doc.spans. Every extracted cluster has its own span group and contains all the spans that refer to the same real-world entity. We can now use this information as we wish for further processing, for example, resolving references in the text. So let's reuse our use case from the beginning and implement this in Python. Alright, in the code I imported spaCy, I imported the doc object of spaCy, I imported Wasabi, which is the printing tool of spaCy. I've loaded in our trained model and processed our example sentence from the beginning. Philip plays the bass because he loves it. And I also printed out the individual components from the pipeline and the found clusters. Here we have the 5 components: the synthesizer, the transformer, the Coref, the span resolver, and the span cleaner. And our 2 clusters, Philip and he, and the base and it. So for our resolve reference function, the general idea is that for every cluster, we take the first mention and use it to replace the other mentions. So our function takes in a doc object and returns a string. So first we have a token mention mapper, which saves the token ID of the mentions and the text of the entity it's referring to. For example, the token he references Philip. So we will replace he with Philip. Then we have an output string which will have the text of the doc with the resolved mentions. And then we start by getting all clusters and check if the key starts with Coref cluster, which is the prefix for all span groups created by the Coref component. We then iterate through every cluster and save the first mention. We then iterate through the other mentions in the cluster. Because these mentions are spans, and for our function we're on a token level, we're taking the first token of every span and save its ID to the token mention mapper, with the string of the first mention of the cluster as value. All the other tokens in the span receive an empty string, so that we replace the mention only one time. We then iterate through every token in the doc, and then check if the token ID exists in our token mention mapper. If yes, we add it to the output string, and if not, we use the original token text. And at the end, we return the output string. So if we run the code, it will give us Philip plays the bass because Philip loves the bass. So it correctly resolved that he refers to Philip and it to the bass. Let's have a look at some other examples. Let's use an example from the blog post. Sarah enjoys a nice cup of tea in the morning. She likes it with sugar and a drop of milk. If we use our function, we get Sarah enjoys a nice cup of tea in the morning. Sarah likes a nice cup of tea with sugar and a drop of milk. Alright, in this video, we trained a Coref model with spaCy and used it to resolve references in the text. As I explained in the beginning, Coref is still in an experimental state, and many features and improvements are coming in the future. If you're interested, feel free to check out the project and the pre-trained model. And if you'd like, leave some feedback in the spaCy discussion forum. I hope you had a good time learning about our new Coref component. Thank you so much for watching, and we see us next time. Bye.